All right, let's take a look at the second page of notes here on section 8.3 on Law of Cosines. This gives us a little bit of application of a situation where we have a side angle side triangle. We have a ship traveling 18 miles per hour from Corsica to Barcelona, which is a distance of 350 miles. Let's go ahead and label that. Looks like this is 350 miles right there. To avoid bad weather, the ship leaves Corsica on a route 22 degrees south of the direct route. After 7 hours, the bad weather has bypassed. Through what angle should the ship now turn to head directly to Barcelona? So we've got 22 degrees labeled. We know that we're going to head back to Barcelona at some point, but we need to find this angle of turn. And notice it's an exterior angle, not an interior angle, so we'll have to deal with that as well. First thing we need to know is exactly how far the ship has traveled. And they give us some information that allows us to calculate that. We know the rate it's traveling, 18 miles per hour. And we also know that it has been traveling for 7 hours. Knowing that we're going 18 miles an hour for 7 hours, we can use distance is equal to rate times time. And calculate the distances traveled is equal to 18 times 7, or 126 miles. Notice the units on this. We have miles per hour times hours, and we're left with miles. So I'm going to label this 126 miles. So we've got those two sides labeled, and notice we have a side angle side situation where we have the included angle between those two sides. We're going to see if we can find some of the other angles and some of the other sides. So let's label these sides. I'm going to say that this is angle C. We'll call this angle B up here, and we'll say that this is interior angle A on the inside. So let's see if we can find the third side length, and we're going to need that in order to find the angles on the inside. So we're going to use the C squared is equal to A squared plus B squared minus 2AB cosine of angle C. We're going to substitute everything we know in, and we should be able to find our third side. So we're going to say C squared is equal to A squared, and we said A is 350, plus side B is 126 squared minus 2 times A times B times the cosine of angle C. And angle C was 22 degrees. We can simplify this. We get C squared is equal to, or approximately equal to 56,598, which gives us a value for C approximately equal to 237.9 miles. I'm going to label that over here. This is 237.9. And we found side C, and that just leaves us with one step. Now that we know all three sides, we can find angle A. And we're going to use the law of cosines again. And we're going to use the modified formula to solve for the angle. So I'm going to say the cosine of A is equal to B squared plus C squared minus A squared all over 2BC. Again, that's just the law of cosines solved for the cosine of A. And we're going to make our substitutions. So I'm going to say the cosine of A is equal to B squared, or 126 squared, plus C squared, and we said C was 237.9 squared minus a squared, which is 350, all over 2 times b, which is 126, times c. And that's 237.9. Please make sure you use use the answer from your calculator. Don't write 237.9 and round off. So we wind up getting, for this, a cosine of a approximately equal to negative 0.834. And the arc cosine gives us angle A is approximately equal to 146.55 degrees. Now, notice that we've solved for angle A. That's not what the question asks us to solve for. We have found the angle that's on the inside, not the angle of the turn. So this is a supplement of the angle that we want. We know that these two have to add up to be 180 degrees. So our angle that we need, the angle of the actual turn, that's going to be equal to 180 degrees minus angle A, or 180 minus 146.55. And that gives us an angle of approximately equal to 33.44 degrees. And this is the angle that the ship needs to turn. Sweet potatoes, quinoa. I'll be down in a minute. All right, that concludes the side angle side situation. We're going to take a look at the second situation, or the second case for law of cosines. And we're going to solve a triangle with side, side, side. Now, when we're doing side, 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 it's important to think about a little bit of geometry. Given triangle ABC, and we can go ahead and label triangle ABC, the smallest angle is always going to be opposite the smallest side. And the largest side, or the largest angle, is always opposite the largest side. So since any triangle can have at most one obtuse angle, it's going to benefit us, and a general rule you should go by here, you should always find the largest angle first. So please make sure that it is always the first one that you find. It's going to make everything a whole lot easier. Let's take a look at the example that they've given us. It says draw a diagram to illustrate the information and solve for the missing sides. And we'll draw a triangle. And this is 8.3 over here. We'll label that as side C, which makes this angle C. A is 20, angle A, and then 15 down below. We'll make this angle B. Note that this angle opposite the largest side, angle A, this is the largest angle. So we want to find that one first. So we're going to start with our law of cosine solve for the cosine of A. And we know that is b squared plus c squared minus a squared all over 2bc. We're going to make our substitutions. We have 15 squared plus 8.3 squared minus 20 squared all over 2 times 15 times 8.3. And simplifying that, we wind up getting the cosine of A is approximately equal to negative 0.4261. And taking the arc cosine to both sides gives us a value for angle A of 115.2 degrees. And we've solved for the largest angle. Notice that it is obtuse. I didn't draw the triangle that way to make that an obtuse angle. You don't need to redraw it, but we just need to recognize that that is an obtuse angle. The other two angles should be less than 90 degrees. Now that we have angle A, we're going to take a look at how we find angle B. We're going to use the law of sines. And we can write this as sine of B, or sine of angle A, which is 115.2 degrees, over side A is equal to sine of B over 15. And we can multiply both sides by 15 to solve for the sine of B. So 15 times the sine of 115.2 degrees all over 20. That's what the sine of B is going to equal. Using a calculator, sine of B is approximately equal to 0.6785. And arc sine of both sides gives us B is approximately equal to 42.7 degrees. Notice we solved for two of the angles. We're just missing the third one. The interior angles must add up to be 180 degrees. So we can say that angle C is equal to 180 minus 115.2 degrees minus 42.7 degrees. And that gives us angle C is equal to, or approximately equal to, 22.1 degrees. And we've solved this triangle. All right, let's take a look at the last example. It says we have two planes leaving from the airport. Airplane A flies west at 300 miles per hour and airplane B flies southeast at 170 miles per hour. So I'm going to draw a picture of this. Never eat soggy waffles. So we've got never eat soggy waffles. The first plane went west. So the first plane is going from the airport west. And the second plane is going to go directly southeast. So we've got those two there. Just notice that this is a 45-degree angle on the interior. This is obviously 90, so this entire angle is going to be 90 plus 45, or 135. Let's translate this drawing to a triangle. And we can draw the two planes. Obviously, this is the airport. We'll call that angle C. And we know that it is 135 degrees. And again, I'm drawing that as an obtuse triangle. We'll label this A, this B over here, and side C, or side A and side B. So we've translated this. This is obviously plane A, and we'll call this plane B. So we've got to figure out how far they are, what the side lengths are of B and A, and they did give us enough information in this problem to answer that question. Very similar to the other example we did with the ship. We know that we have distance equals rate times time. So for plane A, it flies west at 300 miles per hour. So that's your rate. So I'm going to say 300 miles per 1 hour. And it went for 2 hours and 23 minutes. So the time's going to be 2 and 23/60 of an hour. Note the hours drop, and we're left with, if you multiply that on the calculator, we get exactly 715 miles. So the distance for plane A was 715 miles. For plane B, my distance would be, knowing that we went 170 miles per hour, for the same length of time. And again, hours drop, we're left with miles. The distance for plane B is approximately equal to 405.17 miles. So we've got those side lengths, and let's see if we can label them in our diagram. I'm going to say that plane A traveled 715 miles. That's this side over here. I'm going to say 715 miles, and the second plane went 405.17. So we got 405.17, and our goal is to figure out essentially how far apart they are, which is side C. So we need to find side C, and to do that, we know we have a side angle side situation, and we can use the law of cosines. So I'm just going to say C squared equals A squared plus B squared minus 2AB times the cosine of angle C. We fill in what we know, and we can fill in C squared is equal to, and again, it doesn't matter quite which one is A squared and which one is B squared, but it will say 405.17 squared plus 715 squared minus 2 times 405.17. That's A. B is 715 times the cosine of 135 degrees. And this gives us, if you type this in on a calculator, a rather large number. $1,085,080 and 519 thousandths. And if we square root both sides, we get a value for C. It's approximately equal to 1041.7 miles apart. And that is the distance between the two planes after that 2 hours and 23 minutes.